Hello, grade 11s. Welcome to another show where we're continuing where we left off in our discussion of question 1. So, right now we are on the question where we are required to. Question 1.2, where we're given a function of x which looks like a quadratic function or a parabola, and we are asked to solve for x and find the values of d where that function has equal roots. And then the last question we are required to do, solve for that simultaneous equation. And also we're going to be doing question 2, where we will have to use some rules for exponents and also some surd laws, or maybe the K method, and to solve the question. So let's get on right straight to it, starting at question 1.2, because you can see in the previous video where we discussed question 1.1 until 1.4. We're moving on. So the question gives us this function of x who is equal to 5x squared plus 6x minus 7. This is clearly a quadratic function. So the first question asks us to solve for x. We need to solve for x if f of x is equals to 0. So I want to solve for x if this function is equal to 0. So take note, they told us to correct to 2 decimal places. If they tell you to correct to 2 decimal places, it means that you are supposed to use the quadratic formula. And what does the quadratic formula tell us? It tells us that x is equal to negative b plus or minus the square root of b squared minus 4ac. So what you will do here is that you divide this by 2a's, because this is how you use the quadratic formula to solve for x. B is 6, so it's negative 6 plus or minus square root of 6 squared, which is 36, minus 4, a is 5, and 6 is minus 7, divided by 2 times 5. You punch all of this in a calculator and you will find that x is equal to 0.73, or x is equal to negative 1.93. So you have two answers here, because in your calculator you will press for positive and then you press for negative, right? And you will get these two answers. And the next question says we need to discuss the nature of roots. Remember in the first video we discussed how we solve nature of roots. We solve nature of roots by using the discriminant, which says that delta is equals to b squared minus 4ac. If this discriminant value is less than 0, then the roots are not real. But if this discriminant is bigger or equal to 0, then we'll have real roots. We'll have real roots. But if this number is equal to 0, then we're going to have equal roots. Both roots of this quadratic function will be equal. So in our case, they're telling us that we need to calculate the values of d for which this equation with d has equal roots. So this equation will have equal roots even only if the delta equation is satisfied to be 0. So the delta must be 0. So we know that the delta of this function, by substituting here, it's 36. 6 squared is 36 minus 4 times 5 multiplied by minus d. We know that it must equal to 0 for the roots to be equal. I'm not sure if you guys can see what I was writing. I was trying to say here that you substitute the discriminant values from this function accordingly. B squared is your 6. B squared is 6 squared, which gives you 36, minus 4 times a. Your a is the number in front of x squared, and d. It's negative d. So we know that 4 times 5 is 20 times minus d. So 0 is equal to 36. Negative times negative is positive 20d. You move the d to the one side, you get that negative 20d is equal to 36. Therefore, d is 36 over 20 negative, which is also equal to negative 9 over 5, because these fractions can be solved into their simplest form. So d must be equal to negative 9 over 5 for these roots to be equal. Now we move on to the next question. The next question, we need to solve for some simultaneous equations. So we are required to solve for x and y simultaneously. The first equation we're given is minus 2xy is equal to minus 3. This is the first equation that we are given. You can write this equation by having one subject of the formula. You can make it to be x. So x is equal to negative 3. This number, you put it on, jumps to the other side, it changes sign to be positive 2y. This is still equation 1. And then we are also given another equation. xy is equal to 20. So xy is equal to 20. You call this equation 2. So how are we going to solve these two equations simultaneously? We're going to solve by substitution. You guessed it right. So we're going to solve by substitution. How are we going to do this? We're going to substitute equation 1 into equation 2 so that you put the x, when you see x, you put this expression for x. So it's negative 3 plus 2y multiplied by y It's equals to 20. So now we have y's only. We're going to solve for y. Negative 3y, if you multiply it, you find negative 3y plus 2y squared is equal to 20. So you can see this is a quadratic problem, so we want to bring in the 20 this side. So 2y squared minus 3y, the 20 comes over to times negative 20 is equals to 0. So this clearly is a quadratic equation. So you now need to try to factorize this. Try to factorize this 2y squared minus 3y minus 20. How would you factorize this? You can see that this doesn't have a common factor. Since it doesn't have a common factor, we can use a little trick that I learned. So you divide the first term by 2 and you multiply the last term by 2. What will you get? You will get, this cancels out, you get y squared minus 3y minus 40 is equals to 0. Now it's a problem that we are familiar with. It's a trinomial, so we have y both sides. We want factors of 40 that when you subtract give you 3. What are those? It's 5 and 3. That's it. Because 5, no. It's actually, no, we want the factors of 40 that when you subtract give you 3. It's 8 and 5, because 8 times 5 is 40 and 8 minus 5 is 3. So we're going to use 8 and 5, right? Because this is negative and this is negative, the bigger number gets a negative, but this one gets a positive. Remember that here we divided by 2, so you need to put that 2 back. This 2 has to come back, right? And now you need to simplify. Oh, you can see in this bracket we have a common factor. The common factor is 2, so you divide by 2 in this bracket. You're going to find y minus 4. 2y plus 5 is equal to 0. So y is equals to 4, or 2y is equals to minus 5. So y is equals to minus 5 over 2. And that's how you solve for your y. Since now you have your y, you can go back to your equation 2 and solve for x, because you found a solution for y. So we use this equation 2 and substitute in the values we get for y, which is 4. And also we got another value for y, which was negative 5 over 2. So x into minus 5 over 2 is 20. Solve for x here, you get that x is equals to 20. Is x is equals to 20 divided by 4, which is 5. 20 divided by 4, you get it as 5. And then the other one, get that x is equals to 20. You divide this by fraction. You know, when we divide by a fraction, we multiply by its reciprocal, which is 2 over 5. Get that x is equals to minus 8. Are we happy, guys? Is everyone happy? You can write the final answer in tuple form or in coordinate form as 5 and 4, or minus 8 and negative 5 over 2. And there you have it. Solving of simultaneous equations. And now we're going to be working on simplifying some exponential equations and some other monstrous expressions. And we move. This is a grade 11, final grade 11 paper, which is based on the syllabus of the whole year of grade 11. Now we are on to question 2. Question 2 of the final paper. So 2.1. Right, so we're doing question 2 where it deals with more exponents. So we are required to simplify this expression as far as possible using the laws of exponents. So the first step is to break this down. Break it down like this into its constituent parts. Break this 4, you break it down. This 4, the problem with this 4 is that you can change this 4 in such a way that it becomes a power of 2. So this 4 can be seen as 2. This is 2 to the power of 2. You close the bracket because you're substituting this for 4 to the power of 2 to the power of n plus 1, right? All of this is divided by 8. 8 also can be broken down to a power of 2. Just like that. And now, what do? You just apply the exponent rules where it says if the bases are the same, you add the exponents for addition. And when the bases are the same, you subtract for division. So it's going to be n plus 2 because they are multiplied. And then it's going to be plus 2 into n plus 1 because when there's brackets, you use multiplication. Rules for exponents. Even here, there's brackets, you're going to have to use multiplication. And because it's divided, when it goes to the top, you have to subtract 3 into n minus 1. Are we all fine, guys? Simplify this as possible. 2 into these brackets, you multiply in, you get 2n plus 2. You multiply this in, you get minus 3n plus 3. Simplify this further. N plus 2n is 3n. Positive 3n minus this n will make all the n's cancelled out. And then now we are left with 2 plus 2. It's 2 plus 2. Which is 4. 4 plus 3, which is 5. And this is your final answer. Are we all happy? Right, we move on to the next question now, 2.1.2. So right here we see that we have this monstrous surd that we can solve by using the K method, so that we can make it to look much simpler. So you can let K be 2x minus 1, so that you have a simpler question: x plus k multiplied by x minus k. This is your new problem. It's a K problem. It's like this. So how would you go about approaching this? You would have to use your surd laws. Because this is a multiplication of two surds, you can conjunct it into one whole square root. Learn your surd rules. So now it's become this problem. But we can see this is a difference of two squares. Back in factorization, it's a difference of two squares. Right? Happy? Is everyone fine? So this is a difference of two squares. And now we replace back our k, since it was substituted as square root 2x minus k. All of this squared. What are we left with? We are left with x squared. This is going to cancel out. Minus 2x minus 1. Right? Minus 1. So we are left with this problem. It's actually this can be factored out since it's like this. Have your brackets. Brackets are your friends, guys. That's why I had some kind of a silent moment for a while. I was lost because I couldn't see where my brackets are. Brackets are your friend in mathematics, guys. Don't leave out your brackets, they will save you. So we have this now, x squared, multiply this negative into the bracket so that negative and negative is positive, and now we factorize this trinomial. It's an x and an x. We want factors of 1 that when you add give you it's 1 and 1. It must be both negative, so clearly this is x minus 1 squared. The roots cancel out, you've left with x minus 1, and that's it. That's how you solve this question. Expand it. Use factorization. Square roots, the squares cancel out, then you get x minus 1. Moving on to the next question. Still on question 2. They asking for us here. They are giving, in question 2.2, they're giving us a p which is equal to x plus 2 plus x over 3. So the question is, for what values of, we are giving this value of p, we're giving that p is equals to this expression, and we are asked for what values what values of x will p be a real number? So when will this expression be a real number? So it will it will be real if and only if the number under the square root is bigger than 0, is strictly bigger than 0. So this number after the square root must be positive, because if you've put in a negative number here, we will have some math error. So this number under the square root must be bigger than 0, which means x plus 2 must be bigger than 0. Therefore, x must be bigger than negative 2. If x is bigger than negative 2, then we will have solutions for this function. And now, the follow-up question says, we need to show that p is rational if x is equals to 3. We need to show that p is rational if x is equals to 3. Let's substitute 3 into this formula and see what happens. So this is 3 plus 2 plus 3 over 3. We know that 3 plus 2 is 5 plus 3 over 3 is 1. So this is equal to square root of 1, since 5 over 5 is 1 plus 1. This is equal to 2, because the square root of 1 is 1. Final answer you find as 2. Now, the last question in this video we're going to tackle for will be on exponents. So 2.3, this question says we need to calculate the sum of the digits. Calculate the sum of the digits of 2 to the power of 2015 multiplied by 5 to the power of 2019. So we want to take all the digits of these numbers, its digits, and add them together. So first we need to find out what are the digits of this number. What I would do is first break these big numbers down to their simple forms. So you break it down to its simple form. You find that 2 to the 2015 multiplied by 5 to the 2015 multiplied by another 5 to the power of 4, since you've broken it down. Now, you can take out common factor for the power of 2015. 2015 times, what's 5 to the power of 4? It's 625. So 625 times, we know that 2 times 5 is 10. 10 to the 2015. So it's 10 with 2015 zeros. So this number is 625 and a lot of zeros. To be more accurate, it will be 2015 zeros. So our question is to calculate the sum of the digits of this expression. So the sum of the digits is equal to 6 plus 2, the sum of the digits, that's the symbol. This is the symbol we use for the sum of digits, is equal to 6 plus 2 plus 5 plus a lot of zeros. So 6 plus 2, we know it's 8. It's 8 plus 5, we know it's 13. So this is how you do the papers, grade 11s. With more practice, your maths becomes sharper and you can do your work better. Until next time, ciao.